We're first going to take a look at the law of cosines. The law of cosines is actually used for the side, 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 and side angle side cases. Now, I will tell you quite frankly, I don't remember when to use the law of cosines or the law of sines. When we talk about the law of sines, I will tell you actually that I always try to use the law of sines first if I can, and then I know if it doesn't apply that I have to use the law of cosines. But let's take a look at our diagram. It's the same one we used in the previous video. Suppose A, B, and C are angles of an oblique triangle, again a non-right triangle, and A, B, and C are the opposite sides. So I've drawn the diagram. What the law of cosines says, and I've only written one version of it right here, is that the length of two angles, that is given the length of two angles included side, c squared, little c squared, is equal to little a squared plus little b squared minus 2ab cosine of angle C. And so what you might notice, and I always think this is interesting, is that the law of cosines looks a little bit like the Pythagorean theorem, right? We see c squared equals a squared plus b squared, and then we have this other piece. Well, the interesting thing is, if we actually had a 90-degree angle, we really were in a right triangle, and we, I'll call it by mistake, applied the law of cosines, notice the cosine of angle C would be 90 degrees, and the cosine of 90 degrees is 0, so that particular term would just drop out, and we would end up with c squared equals a squared plus b squared. So notice the way that we have this formula. I should let you know that this is not the only version. Right, we could permute the letters around. So we could actually have a squared equals b squared plus c squared minus 2bc cosine a. Or we could have all the combinations. The thing that's going to be important is the angle here and the item that's squared on the other side. Those will always be the same letter. So if this is little c, this will be big C. If this is little a, this will be big A. If this is little b, this will be big B. And then everything else just falls into place. Again, I made the comment about the law of cosines and right triangles, and I actually showed this to you before, or mentioned this before. So let's take a look. So c squared would be a squared plus b squared minus 2ab cosine, and I use the radian measure. Remember that pi over 2, hopefully you recall, is 90 degrees, and you'll see that. Once again, just to sum up, I wrote down the other two versions of the law of cosines.